Welcome everyone to our deep dive into Gemma 3. It's this really cool open source AI model that's been making waves, and today we'll unpack why it's such a big deal, especially for those who, well, prioritize data security. Plus, we'll explore how different versions of Gemma 3, with those varying parameters, how they kind of stack up against each other.
Yeah, you hit the nail on the head there about the data security thing. See, Gemma 3 being open source, well, it means you can run it locally, right? So you can keep all that precious data within your own systems. I think that's a pretty big deal for enterprises, especially those who might be a little hesitant, to rely on those third-party AI providers out there.
It's like having your own, in-house AI expert, isn't it?
Yeah.
But I am a little curious about these parameters you mentioned. What do they actually mean, and why should our listeners care?
Okay, so think of it kind of like choosing the right engine for a car, right? A compact car, it doesn't need the same horsepower as, say, a race car. Gemma 3, it's similar. It offers these different parameter sizes. We've got 1B, 4B, 12B, and 27B. Each one kind of strikes a different balance between speed, complexity, and the depth of its responses.
So it's all about picking the right tool for the job then. But how do we know which Gemma 3 parameter is best suited for a particular task? How do we even make that decision?
Well, that's exactly what this deep dive is all about. To really understand these differences, we put Gemma 3 to the test, see? We asked each parameter size to explain, get this, the concept of ontology and the results. Oh, they were fascinating, let me tell you.
Okay, now you really got my attention here. Ontology, that sounds pretty complex. How did each Gemma 3 model handle it? Were they up to the challenge?
It was almost like watching these different levels of understanding kind of unfold. The 1B model, for example, it kept things pretty simple, very beginner-friendly. It used analogies like Lego blocks and rule books to show how ontology helps structure knowledge.
So the 1B model's like a patient teacher, right?
Yeah.
Explaining a brand new concept to a child. What about the 4B model?
Yeah.
How did its explanation, how was it different?
Well, the 4B model, it definitely offered a more structured approach. It used relatable analogies, things like children's books and organizational frameworks to highlight how ontology helps us organize and share information effectively.
Oh, interesting. So it seems like each model is building on the one before it, adding those layers of complexity. What happened when we made that jump to the 12B model?
Now, this is where things get really interesting, I think. The 12B model, it actually used this analogy of a map to explain ontology. It emphasized how the connections between concepts, they're just as important as the concepts themselves. And get this, it was able to convey those intricate relationships, in a way that the smaller models just couldn't quite grasp.
That's a really powerful analogy, actually. The 12B model can see the whole picture, connecting all those dots. Okay, so now I can't wait to hear about the 27B model. Did it blow us away?
It totally did. The 27B model, it went above and beyond, honestly. It gave this super comprehensive and nuanced explanation, drawing upon real-world examples like apples and human relationships to illustrate even the most complex aspects of ontology.
Wow, that's impressive. It sounds like the 27B model could hold its own in a conversation with a subject matter expert.
Hmm.
But with all this talk about analogies, I'm starting to wonder about the actual performance of these models. Did the larger models sacrifice speed for depth?
Oh, that's a great question, and it really brings us to the heart of those parameter differences. Let's take a look at some hard data, shall we? We can see how each model stacks up in terms of speed and efficiency.
I'm all ears. Let's dive into those numbers. For our listeners out there who might be considering Gemma 3 for their own projects, I think this is where it gets super practical.
Absolutely. We'll break down the pros and cons of each model size, taking into account not just their explanations of ontology, but also those key performance metrics.
Sounds like a plan.
Uh,
Let's kick things off with that 1B model. What are its strengths? What are its weaknesses?
Well, the 1B model, it's definitely the speed demon of the bunch. It delivers responses almost instantly, making it perfect for those real-time applications, things like chatbots or those simple question-answering systems where every millisecond counts.
So speed is the top priority, then the 1B model, it's a clear winner. But I imagine there are trade-offs, Fred.
Right. See, the 1B model, it excels at those straightforward tasks, but it might stumble a bit when it encounters those more nuanced or complex concepts. Its strength really lies in providing those quick, accessible explanations rather than those super in-depth dives into intricate subjects.
It's like having a really quick-witted assistant, someone who's great for those on-the-spot answers, but they might need a little more guidance, a little more hand-holding for those in-depth research projects.
Yeah.
What about the 4B model? How does it compare?
The 4B model, it strikes a really nice balance. It's still pretty fast, but it can handle those more complex tasks, and it even supports multiple languages, which is a huge plus. You can think of it as a versatile all-rounder, something that can adapt to a much wider range of situations.
Oh, that versatility sounds appealing. But are there any downsides to the 4B model? Anything our listeners should be aware of?
Well, while it's definitely more capable than the 1B, the 4B model might still fall short when it's tackling those highly specialized or very technical topics. Its explanations are clear, they're well structured, but they might lack the depth and nuance that you get with the larger models.
Okay, so it's a solid step up from the 1B model, but there's still some room for improvement. So let's move on to that 12B model. What makes it stand out?
The 12B model. Oh, that one marks a significant leap forward in terms of pure capability. It can really delve into those specialized knowledge domains, handle complex reasoning, and generate those remarkably detailed explanations.
It sounds like the 12B model is perfect for anyone who needs more than just, surface level answers. But what's the catch? Is speed a concern with this much power?
Yes, there is a bit of a trade-off. You see, the 12B model requires a bit more processing power, so its responses, they might take a little longer, especially for those super complex tasks where it's really got to flex its intellectual muscles.
Got it. So it might not be the fastest, but it's definitely a powerhouse when it comes to understanding and explaining those complex topics. Okay, now we come to the big one, the 27B model. We've already seen what it can do, but what are its key advantages? What sets it apart from the other models?
The 27B model is in a league of its own. It's capable of, well, synthesizing vast amounts of information, drawing connections between those seemingly unrelated concepts, and generating incredibly nuanced and comprehensive explanations. It's almost like having access to a whole team of world-renowned experts all rolled into one.
So it's like the 27B model can see the forest and the trees at the same time, providing a truly holistic understanding of any topic. But with that much power, I imagine there must be some drawbacks.
You're absolutely right. The main trade-off with the 27B model, it all comes down to speed. It requires significant processing power, which means it could be slower to respond, particularly for those highly complex tasks where it's really showing off its intellectual prowess.
So speed might be something to consider, especially if you're working on time-sensitive applications. But for anyone seeking the most comprehensive and insightful explanations, the 27B model, well, it's the clear winner. But you know what? We've talked a lot about these models in a very abstract way, and I think our listeners would benefit from some concrete examples, like how could these different Gemma3 parameters actually be used in real-world scenarios? What are your thoughts?
Absolutely. Let's try to paint a picture, really illustrate how these models could be put to work.
Great. Let's start with the 1B model. Where would it be the perfect fit?
Okay, so imagine you're building a chatbot for a customer service website, right? The 1B model would be amazing at handling those simple questions and requests. Things like checking order status or maybe resetting a password. And its speed, well, that ensures a smooth and seamless experience for the customer.
Okay, yeah, that makes perfect sense. It's like having a virtual assistant who can provide those instant answers to those really common inquiries. What about the 4B model? What kind of real-world application would benefit from its versatility?
The 4B model, it would be ideal for a chatbot that needs to handle a wider range of questions, maybe even support multiple languages. For instance, a travel booking website. They could use the 4B model to help users find flights, book hotels, even offer some basic travel recommendations, all in their native language.
It's like having a multilingual travel agent right in your pocket. Now, where would the 12B model come in handy? I feel like its ability to really delve into that specialized knowledge, that seems particularly promising.
Oh, you're spot on. Imagine a researcher who's studying a very specific scientific field, right? The 12B model could be incredibly valuable for analyzing research papers, synthesizing those key findings, even generating hypotheses for further investigation. It's almost like having a dedicated research assistant, someone who can process vast amounts of information and distill it into those meaningful insights.
It's amazing to think about how AI can amplify our capabilities in so many different fields. And finally, where does the 27B model fit into this real-world landscape?
The 27B model, it truly excels at tackling those really complex, very demanding tasks. So imagine you're a doctor and you're trying to diagnose a rare disease. The 27B model, it could analyze the patient's medical history, their genetic information, current symptoms, drawing on its vast knowledge base to provide those potential diagnoses and treatment options.
Wow, it's like having a whole team of specialists all working together to provide the most accurate and comprehensive medical insights. It's mind-blowing to think about the potential. I'm curious, when you looked at those different responses to the ontology question, what specifically stood out to you? Was it just the analogies, or was there something more?
Well, the analogies were definitely eye-catching, but what really impressed me was how each model used them to build a coherent and engaging explanation. It really showcased their ability to not only process information, but to communicate it effectively, tailoring the complexity to its own level of understanding.
So it's as though each model has its own distinct teaching style, catering to different levels of comprehension. It makes you wonder, do these models actually understand ontology? Or are they just mimicking human comprehension through, some really sophisticated pattern recognition?
That is the question, isn't it? It's a question that continues to spark debate, among philosophers and AI researchers. Do these models possess genuine understanding in the same way that humans do? It's hard to say for sure. But what's clear is that they can learn patterns and relationships between concepts. Then they can utilize those patterns to generate those remarkably human-like responses.
So maybe it's not understanding in the traditional sense, but it's definitely a form of advanced pattern recognition that allows them to mirror human comprehension in a really remarkable way.
Precisely. And as these models evolve, they're becoming even more sophisticated. Who knows what levels of understanding they might eventually achieve. It's a really exciting time to be exploring the frontiers of AI, that's for sure.
I completely agree. But with all this talk about AI's growing capabilities, it makes you wonder about the role of humans in this rapidly evolving landscape. Like, where do we fit in as AI becomes even more integrated into our lives?
That's a crucial question, and it's one that deserves a much deeper conversation for sure.
Right. It's not about AI replacing humans. It's about finding ways for AI and humans to collaborate, to complement each other's strengths.
Absolutely. We can leverage AI's ability to process and analyze these huge amounts of information, while humans, well, we can provide the critical thinking, the creativity, and those ethical considerations that are so essential for responsible AI development and deployment.
It's about finding that sweet spot, that synergy between human ingenuity and AI's computational power. But before we delve deeper into those ethical considerations, which we will in the next part, let's just recap what we've learned so far about Gemma3 and its different parameters.
Sounds good.
First and foremost, it's clear that choosing the right Gemma3 parameter really depends entirely on the specific needs and priorities of the user. There's no one-size-fits-all solution here.
Absolutely. It comes down to finding the right balance, that optimal balance between speed, complexity, and the level of detail needed for the task at hand.
Exactly. If speed is paramount, then that 1B model, that's your go-to. If you need a more versatile, multilingual option, then the 4B model steps up to the plate.
And for those tasks that demand in-depth analysis and specialized knowledge, well, the 12B and 27B models, they offer incredible power and insight. It's almost like having a whole team of AI specialists, each with their own unique skill set.
I love that analogy. Now, before we wrap up this part of our deep dive, I want to leave our listeners with a thought-provoking question. So considering the rapid advancements we're seeing in open source AI, how might models like Gemma3 actually change the way we access and understand information in the future? Like, what new possibilities might emerge as these powerful tools become more accessible to everyone?
Ooh, that's a fantastic question to consider for sure.
We'll be delving deeper into the potential implications of Gemma3 in the next part of our deep dive.
I can't wait to explore those possibilities with you.
But for now, we encourage all of you out there to explore Gemma3 for yourselves. Discover its potential applications. You might be surprised by what you find.
Happy exploring.
Welcome back to our exploration of Gemma3. It's been a really fascinating journey so far. We've seen how it's different parameters, those different sizes, how they handle those complex concepts. But now I'm really curious about what's happening like under the hood. What actually makes Gemma3 tick?
That's a great question. Now we get to dive into the fascinating world of its architecture. So Gemma3, it's built on this thing. It's called a transformer-based neural network, and it allows it to process information in a way that's totally revolutionary compared to, like, those older language models out there.
Okay, you're going to have to break that down for me a little bit.
Yeah.
Transformer-based, that sounds super technical. What does it actually mean? In a way that, like, makes sense for those of us who aren't AI engineers.
All right. So imagine you're reading a book, right? Traditional language models, they would process each word one by one, kind of like moving along a line. But a transformer can analyze all the words in a sentence at the same time, considering their relationships and like the whole context.
So it's like the model can grasp the whole picture, not just those individual pieces of the puzzle.
You got it. And this ability to understand context, that's what allows Gemma 3 to generate such coherent and natural sounding responses. It's a total game changer in the field of language processing.
Okay, that's starting to make sense. But how does it actually do that? What's the magic behind this contextual understanding?
Well, the magic, it lies in this mechanism called attention. Think of it like a spotlight that focuses on the most relevant parts of a sentence or even a whole document, you know?
So it's similar to how we as humans like focus on the most important information when we're reading or having a conversation.
Precisely. By zeroing in on those key elements, the model can decipher the meaning, the intent behind the words, and that leads to a deeper understanding of the text as a whole.
That's so fascinating. It's not just processing words in isolation.
Mhm.
It's about understanding their connections and their significance within a given context. It's almost like it's like the model is learning to think a little more like a human.
That's a great way to put it. And that's what sets transformers apart from those previous architectures. You see, they enable those language models to go beyond that simple pattern recognition and move towards genuine language comprehension.
This is all so incredibly complex. I mean, it's really amazing to think about all the research and brain power that goes into creating these models.
Yeah, it's remarkable, isn't it? And what's even more exciting, I think, is the incredible pace of innovation in this field. Like new techniques and architectures are constantly emerging, always pushing the boundaries of what AI can do.
It's mind-boggling to think about the possibilities, really. But let's bring it back to Gemma 3 for a second. We've talked about this transformer-based architecture, but are there other technical features, things that contribute to its really impressive performance?
Oh, absolutely. So Gemma 3, it incorporates several cutting-edge techniques, including things like masked language modeling and next sentence prediction. These play a crucial role in its ability to understand and generate that really human-like text.
Okay, let's unpack those a little bit. Masked language modeling, that sounds intriguing. How does that actually work?
So imagine you're playing a word game, like one of those where you have to guess a missing word in a sentence. That's essentially what masked language modeling does. So during training, the model is fed text, but with certain words masked out, hidden, and it has to predict what those missing words should be.
So it's like a giant fill-in-the-blank exercise for the model.
You got it. Exactly. And by training on massive amounts of text data this way, the model develops this really deep understanding of the relationships between words, how they fit together to make those meaningful sentences. It's almost like learning grammar and vocabulary through total immersion.
Oh, that makes a lot of sense. It's a really clever way to teach the model, to train it, to think about language structure. So what about next sentence prediction? How does that contribute to Gemma 3's capabilities?
Well, next sentence prediction. It's another one of those powerful tools that helps Gemma 3 really understand the flow and coherence of language. It learns to predict whether two sentences logically follow each other, basically grasping the natural progression of ideas in a text.
So it's like teaching the model to recognize those subtle connections, those transitions that make a piece of writing flow smoothly and logically. It's almost like learning the art of storytelling.
That's a fantastic analogy. And by mastering this skill, Gemma 3 can generate text that isn't just grammatically correct, but it's also logically sound and really engaging. It's moving beyond just putting words together and into the realm of coherent thought and expression.
This is all so impressive, but it makes you wonder, with all these intricate techniques at work, how do we even begin to measure how effective these language models actually are? Like, what are the benchmarks? What are the yardsticks we use to evaluate their performance?
That's a great question, and it's an important one. Evaluating language models, it's a very multifaceted process, and it goes beyond just those simple metrics. We need to assess a whole range of factors, things like fluency, coherence, factuality, and relevance. It's not just about whether the model can generate text, it's about the quality and the meaningfulness of that text.
Okay, so let's dive into each of those factors a bit. What do we mean by fluency when we're evaluating one of these language models?
Fluency, that refers to how smoothly and naturally the generated text actually reads. Is it grammatically correct? Does it follow those rules of syntax and punctuation? And does it actually sound like something a human would write? We're really looking for that seamless flow, that natural cadence that characterizes human language.
So it's like judging the model's writing style. Can it convincingly pass as something written by a human?
Exactly. And there are several different techniques we use to assess fluency, things like perplexity scores which measure how well the model predicts the next word in a sequence. And we also use human evaluation, where people actually judge the naturalness and readability of that generated text.
That's really interesting. Now, how does coherence differ from fluency? They seem connected, but I'm guessing there's a nuance there.
You're right, they are definitely intertwined. But coherence, it goes a bit deeper than just grammar and syntax. It's about whether the text makes sense logically. Do the ideas flow together in a way that's easy to follow? Does it have a clear structure? Are the sentences connected and relevant to each other? We're looking at the big picture here, the overall logic and flow of the text, not just the individual sentences.
So coherence is more about the overall message and how effectively it's communicated, not just the technical correctness of the language.
Precisely. And to assess coherence, it often involves human judgment, because it can be quite subjective. What might seem perfectly coherent to one person might not be to another. It's about capturing that kind of elusive quality of human understanding and interpretation.
That makes sense. Now, what about factuality? How do we make sure these language models are generating information that's accurate and reliable? I mean, this seems especially important as these models are being used for tasks that really rely on factual information, like summarizing those research papers or answering very specific questions.
You've hit on a crucial point. We absolutely can't just assume that the information generated by these models is accurate, especially since they're trained on these huge amounts of data, and that data might include inaccuracies or biases.
So how do we measure factuality? How do we ensure that the information is actually reliable?
There are different techniques we use, things like comparing the model's output to known facts, or we might use human annotators to fact-check the generated text. However, even with these safeguards in place, it's super important to remember that even the most advanced language models, well, they're not infallible. They can still sometimes generate information that's incorrect or maybe even misleading.
So it's like any other source of information out there. We have to be critical consumers, always double-checking those facts and considering the source. Blindly trusting AI to be 100% accurate, well, that's a recipe for disaster.
Absolutely. It's crucial to be aware of the limitations of these models and to use them responsibly. They are powerful tools, but they require human oversight and critical thinking to ensure accuracy and reliability.
Well said. Okay, so what about relevance? What does that actually mean when we're talking about evaluating these language models?
Relevance, it's all about making sure the model stays on target. We need to determine if the output is addressing the prompt or the query, and if it's providing information that's directly related to the topic. Is it staying focused? Or is it veering off on tangents? Is it giving us information that's not really pertinent to the question?
So it's about making sure the model is answering the right question, not just throwing out a bunch of random information, however impressive that information might be.
Exactly. We want to see how well the generated text aligns with the user's intent. We want the model to be a helpful and informative tool, not a source of confusion or irrelevant data.
It's like making sure the model is a good conversationalist, someone who stays on topic and responds appropriately to the flow of the discussion. Wandering off on tangents might be charming in a human, but it's not really what we're looking for in an AI assistant.
That's such a great way to put it. We want the model to be a valuable collaborator, providing relevant insights and information that actually enhances our understanding and helps us achieve our goals.
These are all such important considerations. Evaluating language models, it sounds almost as complex as building them.
It really is. And as these models continue to evolve and they're becoming more sophisticated all the time, we're going to need to develop even more nuanced and comprehensive evaluation methods to keep up. It's a constant challenge, but it's absolutely essential to make sure these powerful tools are being used responsibly and effectively.
I completely agree. Okay, so we've covered a lot of ground here, from those technical inner workings of Gemma3 to the complexities of actually evaluating its performance. It's clear these models are incredibly powerful tools with a huge range of potential applications. But as with any powerful tool, there are potential risks. There are ethical considerations that we really need to think about carefully.
That's such an important point. We can't just focus on the technical capabilities. We need to really grapple with the ethical implications of these models and ensure they're being used to actually benefit humanity, and not to cause harm.
That's a perfect segue into the next part of our deep dive, where we'll really delve into those ethical considerations and explore the future of AI. Stay tuned, everyone, because the conversation, it's about to get even more intriguing as we explore those broader implications of models like Gemma3. Welcome back to our final segment on Gemma 3. It's been quite a journey, hasn't it?
Hmm.
We've talked about its impressive capabilities, its intricate technical architecture, and now, well, it's time to kind of shift gears and look ahead a bit. We ended the last part talking about those ethical considerations, and I think that's the perfect place to pick up our conversation. As AI becomes more and more intertwined with our lives, how do we make sure these powerful technologies are developed and used responsibly? How do we make absolutely sure that AI serves humanity as a whole and not just, a select few?
That's the million-dollar question, isn't it? And it's not just a concern for, those big tech companies or those policymakers. It's something we all need to be thinking about, actively engaging with. AI isn't some far-off futuristic concept anymore. It's already shaping our world in so many ways, actually.
It really is. I mean, AI is already integrated into everything, from personalized recommendations to like medical diagnoses. It's almost become, like the air we breathe, invisible, but totally essential.
Yeah.
And just as we care about the quality of the air we breathe, we need to be just as concerned about the cleanliness, so to speak, of the AI that surrounds us.
I love that analogy. It's so true. We need to be thinking about ethical algorithms, making sure that fairness and transparency and accountability, they're all baked into these systems right from the start. It's not just about the code itself, it's about the values that are embedded in that code.
It's like building a house. You need that solid foundation and a well-thought-out blueprint to make sure the structure is safe, stable, and that it serves its intended purpose, right?
Yeah.
You can't just, throw some bricks together and hope for the best.
Exactly, and that's where Gemma 3's open source nature is such a huge advantage. That transparency, the community involvement, those are so crucial for responsible development. It allows for much greater scrutiny, more collaboration, and it fosters this shared sense of ownership over the technology.
It's like having a public park instead of a private estate,
Yeah.
right? More people can enjoy it, they can contribute to its upkeep, and they even have a say in how it's managed.
Precisely. And that open approach, it really fosters this collaborative spirit, and that leads to more innovative and ethical solutions. It's not just one company dictating the terms, it's a whole community working together to shape the technology for the benefit of everyone.
That's a powerful concept. It's almost like democratizing AI, giving more people a voice in shaping its trajectory. But transparency is just one piece of the puzzle, isn't it?
Yeah.
What about accountability? Who's responsible when things go wrong? Because as AI systems become more complex, more autonomous, it seems like pinpointing responsibility could get really tricky.
It's a valid concern, definitely. We need clear guidelines, clear frameworks to really determine accountability when these AI systems make mistakes or, even cause harm. And it's not about, pointing fingers or placing blame. It's about having systems in place to address issues quickly, to learn from them, and to prevent them from happening again.
So it's like establishing a legal system for AI, right? Figuring out the rules of the road in this new technological landscape.
Exactly. We can't afford to wait for problems to pop up before we scramble for solutions. We need to be proactive, anticipating potential challenges, and building in safeguards from the very beginning.
That makes a lot of sense. But I'm curious, who should be driving this whole conversation? Is it solely the responsibility of the tech companies, or do governments and individuals have a role to play as well?
It's definitely a shared responsibility, It takes a village. Tech companies have a crucial role to play in designing and developing those ethical AI systems, but governments need to step up too. They need to establish those clear regulations, those guidelines that ensure these technologies are used responsibly and that they don't infringe on individual rights or like our shared societal values.
So it's a three-legged stool then. Tech
Yeah.
companies, governments, and individuals all need to be actively involved in working together.
Exactly. And individuals, we have a responsibility to stay informed, to engage in those critical conversations, and to hold those in power accountable. We can't just be passive bystanders here. We need to be active participants in shaping the future of AI.
It's about empowering ourselves with knowledge, understanding not just how to use AI, but also how it impacts our lives, our society as a whole.
Precisely. We need to be informed citizens, not just consumers in this technological revolution. We need to ask those tough questions, demand that transparency, and advocate for ethical development and deployment of these really powerful technologies.
Well said. Now, I want to shift gears a bit and talk about the potential benefits of AI, especially models like Gemma 3. We spent a lot of time on the risks, but it's important to acknowledge the incredible opportunities that AI offers, right?
Oh, absolutely. AI has the potential to revolutionize so many fields, from healthcare and education to transportation to even environmental sustainability.
Mhm.
It's a tool that can help us solve some of the world's most pressing problems, and it can help create a more just and equitable society for everyone.
It's almost like having a superpower at our disposal. A tool that can amplify our abilities, help us reach new heights of human ingenuity and innovation.
I love that analogy. Think about the potential of Gemma 3 in healthcare, for example. It could help doctors diagnose diseases earlier, more accurately. It could help personalize treatment plans based on each patient's unique data. And it could even accelerate drug discovery, leading to breakthroughs in the fight against diseases that have plagued humanity for centuries.
It's like having a world-class medical expert in every pocket, available to anyone, anywhere, no matter their socioeconomic status or where they live. And what about education? How could AI transform the way we learn and access knowledge?
Imagine personalized learning experiences, perfectly tailored to each student's unique needs and learning style. AI could provide real-time feedback, identify areas where students are struggling, and it could create customized learning materials that adapt to their individual pace and preferences.
It's like having a personal tutor for every student, guiding them along their educational journey, helping them reach their full potential.
Exactly. And think about the impact that could have on accessibility and equity in education. It could really break down those barriers that have traditionally prevented so many individuals from reaching their educational goals.
It's inspiring to think about all the positive ways AI could impact our lives. But, as we've discussed, we need to proceed thoughtfully, carefully, making sure that AI is developed and used in a way that benefits everyone, not just a select few.
You are absolutely right. We need to stay vigilant, ensure that AI is a force for good, not a tool for division or inequality.
I'm optimistic. I truly believe that with open dialogue, with ethical considerations, and a shared commitment to responsible development, we can harness the power of AI to create a brighter future for everyone.
I share your optimism. It's a journey that we're all on together, and it's up to all of us to shape where we end up.
That's a perfect note to end on. Thank you all so much for joining us on this incredible deep dive into the world of Gemma 3. We hope you've learned a bit more about its capabilities, its potential, and those all-important conversations we need to keep having as AI becomes an even bigger part of our lives.
It's been a pleasure exploring all these fascinating topics with you.
And to all our listeners out there, keep exploring, keep questioning, and keep the conversation going. The future of AI, well, it's in our hands.